This is Algebra 2 at Trig, 1C.1a. We're going to learn to factor. We're going to be factoring in three different focuses. One's going to be when a equals 1. We're going to have special cases of factoring, and we're also going to look at some that have a leading coefficient other than 1. So lots of factoring today. We will keep revisiting this over the next many days. First of all, what are these expressions made of? We have a monomial. And a monomial is an expression that is an integer, a variable, or a product of an integer and variable. For example, it could be 3x, it could be 5x squared. Those would be examples of monomials. Anything multiplied together without any pluses or minuses involved. Negative is okay, but not minuses between terms. A binomial is the sum, either positive or negative, but the sum of two monomials. That's called a binomial. That's going to look like x plus 2 or 3x minus 7. Those would be called monomials. Even 5x squared minus 2x, that would be a binomial. It has two parts. They're separated by a plus or a minus. Then you have a trinomial. A trinomial is the sum of three monomials. So often we would look at that as x squared minus 3x plus 10. That would be a trinomial. That's made up of three pieces, all added or subtracted in between each other. In the past, we have worked with intercept form. So when we're factored and we have two binomials that are multiplying each other, this is called factored form. It kind of looks like intercept form of the polynomials we were graphing. When we multiply this, x times x gives you x squared, x times 8 gives you 8x, negative 7 times x is negative 7x, and negative 7 times 8 is negative 56. Your 8x and your negative 7x are adding together to be 1, and that's how we expand this to become x squared plus x minus 56. That came from multiplying two binomials together. We've done that before. But now we're going to go the other way. We can reverse this process and we're going to factor. What we're going to be looking for is what is the coefficient out in front. Right now we're going to look at coefficients as being a 1. This front number in front of the x squared is always a 1. You might say, but that's not a 1, but we'll talk about it. That's not exactly a 1, but we'll talk about it. So we're looking to have that be a 1. Those are the easiest ones to do. In that case, we are looking for what multiplies to be the c value, which is this term, and what adds to be the b term. Now, it might be a good habit to not just look at the c value, but to do A times C. Do the first term times the last term. That'll be a better practice. But really, all you have to do, if the leading coefficient is a 1, is just look at the last term, because it's 1 times C, which is C. But I'll warn you that it might be a benefit for you to get used to 1 times C. So if that's not a 1, you'll be ready to make the next step. Let's take a look at what some of this factoring is about. Here we have our A term. Right now we're expecting those to be 1s. Our B term and our C term. We want to factor this apart so it turns into 2 binomials. So we're looking for 2 values, P and Q, that are going to add to be the B term and are going to multiply together to be the C term. So in terms of numbers, we're looking for 2 numbers that multiply to be 6 and add to be 5. What I would suggest to you is to use a sum and product table. And you put your product, what multiplies, that's this term here, C, what multiplies to be 6 and adds to be your B term, which is 5, put that into your table. Now you're trying to come up with all the different ways that you have a multiple to become 6. That's actually limited. There's only 1 times 6 and 2 times 3. There's an infinite number of ways to add to become 5. So we're not going to make a list of all the ways you can add to become 5. When you start to think about all the negative values that could add to it, it would all get confusing. So here we are looking at your 2 sums. This one adds to 7, this one adds to 5. So of course we want the one that adds to 5. So then we take our 2 and put it in, and take our 3 and put it in, and we factored it apart. You're done. You did it. So here we're going to come down and try 3 different problems. Why don't you, we barely even learned it, but why don't you take a look and see if you can take what we've talked about so far and get anywhere with any 3 of these problems. B and C have a whole extra step to it, but A, you might be ready to answer A as we speak, after you saw the introduction to how we factored here. So try that. Pause the video, come on back, and we'll walk you through it. So we start out, you might already know your numbers, but I suggested to take the A times the C, which was the product was 2 that has a sum of 3. You know that 1 and 2 is the only way to multiply to be 2, and of course that adds to be 3. So we have found the numbers that we're looking for. So we're ready to put those into parentheses as x plus 1, because that's a positive 1, and x plus 2, because that's a positive 2. So we have 2 binomials. Now to check your work, you can FOIL this together, x squared, 2x, plus x, plus 2. Collect your like terms, and you'll see that you got what you started with. So check that worked. You do not need to ask, did I do this right? If you were to take a factoring quiz, you don't have to wonder if you did the right answers. You can always check every single answer, so you know if you made it correct or not. Let's move on to the next one. This next one has an A value. It's not done exactly the same way. You cannot say what multiplies to be 6 and adds to be 8. It won't work that way. So you have to try something different. We notice that they're all even numbers. So I wouldn't use the word divide because that kind of implies it disappears. But let's factor it out. It's called a GCF, greatest common factor. And we'll pull that multiple of 2 out of every one. It's kind of like dividing by 2. But we don't want to lose that 2. So we'll call it factoring when we pull that 2 out to the front. Now we look here, and we're looking to multiply to be -3. That adds to be 4. So I come to my product table. I have my A value as 1. And I come over and I multiply my -3. That adds to be 4. So to multiply to be a negative, I know my 2 signs have to be different. And to add to be a positive, the larger number has to be positive. So my only ways to do this is -1 and 3. That's the only way you can multiply to be -3 and add to be a positive number. But when you add these together, you get 2. There's no other option. Even if I tried to be crazy and do this, I don't even get my 4. So this doesn't have multiples. You've already figured out you don't have to spend extra time trying to figure out if this is possible. You have eliminated all the choices. This is called a prime trinomial. It does have a GCF. That you could do. But it doesn't have another step. So this trinomial here is prime. Let's come on over and try letter C. Notice how letter C has a negative in front of the p squared. With the negative, we can factor that out. You can write the 1, you don't have to write the 1. That's going to leave us with p squared, a -24p, and a positive 144. So we factored our negative out. You do not want to factor with a negative term in front of your square. You want to pull that out. So we factored it out. That means we have to change all the signs. Now we're ready to work with this. This is actually a special case type, which would give us a shortcut. But if we don't recognize that, we would say what multiplies to be 1 times 144, and what adds to be -24. If you happen to know your numbers, you don't need to make this table. You can go right to it. But in a lot of cases, if it's a tricky factoring one, it's going to be your advantage to write them out. So I would suggest always starting with 1. Notice to multiply to be a positive 144, I know my 2 signs have to be the same, either both positive or both negative. That's how you multiply to be a positive 144. They're either both positive numbers or they're both negative numbers. To add to be a -24, you know your numbers would have to be negative. They can't be positive. And it's not a choice for them to be positive and negative. So they have to both be negative. So we'll look at our different possibilities to multiply to be 144. I know 1's not the answer, but I would suggest to you to start with 1. Then try 2. Don't skip around and see if you can land on it. Start with 1, go to 2, and then you just start working your way through. 3 goes into 14 4 times with 2 left over, so that's going to be 48. 4 goes into 14 3 times, with 2 left over, that's going to be 36. 5 doesn't go into something that ends in a 4, so I don't even have to try that. 6 goes into 14 2 times with 2 left over, so that's 24. None of these are adding to be 24 yet. Let's see if 8 goes in. 8 goes into 14 1 time with 6 left over, 64, so that's going to be 16. And then 10 doesn't go in evenly, but 12 does. And that's going to be 12. Sorry, these would be negatives also. 12 times 12. Wow, that was a tough one. You had to work your way all the way through. But if you don't skip terms, that will help you out. It looks like I skipped 9. 9 might even have worked, huh? But here we go. That's your negative 24. So now we know what our answer is. It's negative 1, because you bring your GCF out in front. P minus 12. P minus 12. And some people might say, can we do P minus 12 squared? And that would be great. This was a little intimidating because our list was so big. We had to try so many options.
Is there any shortcuts?
This particular method does have a shortcut to it, and we'll talk about that here in the special patterns. We have a special pattern called the difference of two squares. Notice that the difference of two squares is a binomial. It's made up of two monomials. It's a binomial. For example, would be down here, x squared minus 4. This is not done the same exact way we did this. We don't typically use tables to help solve this, to help factor it. It's not solving, it's factoring. So the rule is, if you can take the square root of the first term, and if you can take the square root of the second term, then you can write it as a minus b, a plus b. When you try to test that, a minus b, a plus b, when you multiply that together, you get a positive ab, you get a negative ab, and you get a negative b squared. These two terms cross off, and you're left with a squared minus b squared. That's what we started with. All right, let's take a look at our first example. Now, does this have just two parts to it?
No, it's 2x's.
This has two parts. It's called a binomial. This would fall underneath our definition of difference of two squares. Because it's a minus, it has to be a minus. Can't be a plus. And they're two perfect squares. I can take the square root of my first term, and I can take the square root of my second term. Don't consider your second term negative 4. Consider it just 4. You're taking the square root of something squared, so you get dx. If you can do that, like we did up here, if you can take the square root of the first term and take the square root of the second term, then you're going to have x minus 2, x plus 2. Let's test this to see if it worked. X times x is x squared. Multiply through to get 2x minus 2x and a negative 4. These are going to cross out, and you're left with x squared minus 4. That worked. That means this is your answer. This is your factored form. So now, we're going to come on over here to our second one. Is this the same type of question? Or is it more like this first type? You've got to decide that. This is the tough part about factoring. There's multiple ways to handle different problems. Or there are different problems that have to be handled a different way. So you've got to determine what type of problem. How am I going to go and handle this one? I notice that this has two parts. So it's a binomial. I notice that there's a negative in the middle. So I'm going to try to factor this. I'm going to use the difference of two squares because I believe you can either use your eyes or you can physically write it. Can I take the square root of the first term? And the answer is yes. 3x times 3x is 9x squared. Can you take the square root of 36? And the answer is yes. The square root of 36 is 6, or 6 times 6 is 36. So if you can take the square root of both of those terms, and it's a minus in between, then you can call it 3x minus 6, 3x plus 6.
What if there's not a minus?
It has to be a minus in there, otherwise it's not factorable. Now, if this is your final answer, this answer is incorrect. So you need to pull out every factor that's available. So if you look in here and you see 3 and you see 2 times 3, you have to pull that 3 out. So that's going to give us x minus 2. Now I'm going to pull another 3 out. And when I multiply it back in, it would be 3 times x. And what I'm missing on this side, what does it take to make the 6, would be 3 times 2. So I'm just doing the GCF. Since I pulled out 2 items, the best answer that you can give would be 9, x minus 2, x plus 2. That's the correct answer. You may have noticed something else. What was another way you could have come across this answer? So you may have noticed up in the beginning problem that both of these had a GCF in the very beginning. If they had a GCF later, they could have had a GCF in the beginning, or they would have had a GCF in the beginning. So I noticed they both can be divisible by 9, so I'm going to factor out a 9. And that's going to leave me with 9 times x squared and 9 times 4. And we know that x minus 4 is x minus 2, x plus 2. Because we can take the square root of both, and it's x and 2, and we write them out, just like we did here. So this is your quicker method, but it's only good if you notice that you had a GCF that could come out. If you didn't notice, then you did the work, and you saw your individual GCFs, and you multiply them together. You get the same result either way. The order in which you write the parentheses, x minus 2, x plus 2, that will not matter. You can do 9, x plus 2, x minus 2 if you wish. Just like any 2 times 3 and 3 times 2, those multiply to be 6 no matter what. All right, our next one. We look here. Is this the same type of problem? I see 3 pieces, so this is a trinomial. Is this the type of trinomial that we were doing in the very beginning? This has an a value. And we haven't learned about if the a value is bigger than 1. Is this having a GCF in it? You got to try all these options. Is there a number that can be factored out of all 3 terms? And no, we don't have divisible by 4 out of everything. Out of some of them, but not out of everyone. So you can't do that. So let's look at another shortcut method that might work for this. So here, we're looking at what's called a perfect square trinomial. We need a term that is squared, another term that is squared, and the middle term has to be 2 times those two multiplied to each other. So in other words, can you take the square root of a squared? And can you take the square root of your c term, which is b squared? And is the middle term 2 times those two values multiplied together? 2ab. Yes, it is. So your answer, your factored form to this, is a plus b, a plus b. And we will typically call that a plus b squared. And the same thing stands for if it's a minus in front of your middle term. This would become a minus b with an a minus b squared as your shortcut. So let's see if that method's going to work here. What did we talk about? What needs to be true for this to be that type of a problem? It's clearly not the difference of 2 squares. It's not that type of problem. Is it a perfect square trinomial? Can you take the square root of the first term? Can you take the square root of 4x squared?
Yep.
Can you take the square root of the c term? Square root of 1 is 1. And is the middle term 2 times those two put together? 2 times 2x times 1.
Yep.
That gives me 4x. And yes, it is. So this is following a perfect square trinomial pattern. So what I can do is take my 2x plus 1. If I want to write it twice, I can write it twice. 2x plus 1. I can FOIL that together and see if I get what I started with, which I would. Or the shortcut is just write it with 2x plus 1 squared. Which, by the way, you cannot distribute the square in. Distributing the square in will not give you a middle term. That'll be a common mistake come our next test. You would have to write them separately, then you can FOIL it together. Let's try letter D. Pause the video, give this one a try, and see what you think. All right, let's take a look at this last one here. So the first thing, you notice that this has 3 parts to it. One concerning issue is that it has an a value that's bigger than 1. We'll shortly learn how to do those types. But it also has a negative in front. I don't like the negative in front. But I also notice that everything's divisible by 5. So I'm going to factor out my GCF like so. Now I have a trinomial that has an a value of 1 that I can make a table for and see what multiplies to be negative 10, adds to be negative 3. That would be 2 and negative 5. That multiplies to be negative 10. That adds to be negative 3. And because it's a leading term of 1, I'm able to drop that right into my parentheses, x plus 2, x minus 5, And don't forget your GCF sitting out in front as -5. And there you go. Okay, before we move on, let's go ahead and try x squared plus 6x minus 7. Can you factor that? Pause the video, give that one a try, then come on back. All right, when we try this one, I see that it's a trinomial. So I'm going to take my a times my c. That adds to be 6. I know my two signs have to be different because they have to multiply to be a -7. And my larger number has to be positive. So -1 and 7 multiplies to be 7 and adds to be 6. So that's going to be x minus 1 and x plus 7. If I was to FOIL this out, I could test my answer to see if I have the correct answer. 7x minus 1x gives me 6x. So I factored it. Now we move into the final type. What happens if our leading coefficient is other than 1? What if that leading coefficient is a 10 and I don't have a GCF to pull out? Well, we're going to do it, at least in the beginnings, the same way we did the other ones. We have to do our A times our C. You have to incorporate that A term. So we're going to multiply those to get -30. That adds to be -1. What are your different ways to multiply to be -30? Well, you know your signs have to be different and your larger number has to be negative. Your larger number has to be negative. So 1 and -30, 2 and -15, 3 and -10, 4 doesn't go into that, 5 and -6. Hey, that's it. So I found what multiplies to be -30 and adds to be -1. This one added to -7, -13, -29. That's irrelevant, doesn't matter. I just needed to find the one that added to -1. Now, what do I do with these two numbers? You do not, listen to this carefully, you do not just drop them into the parentheses. So we need to take our first term, which is 10x squared. We need to take our last term, which is -3, and we have to put our 1x in the middle. Our 1x is made up of these two numbers.
Do you only do this when A is not 1?
This is a method, it's called factor by grouping, and it's used when the leading coefficient is other than 1. So now, I'm pretty close to the answer, so don't give up on me yet. I circle my two groups. That's the grouping part. Factor by grouping. I just group them together. What can I factor out of my first circle? 5 and an x. What would be left inside if I pulled a 5 out of each of those? 5 times what makes 10? So it would be 2x, because x and x makes x squared. 5 times what makes 5? So it would be x plus 2 left inside if I divided out or factored out the 5x. Bring down this sign. Now, what can I factor out of this group? I can factor out a 3. The negative's taken care of, but it would be negative 3. What would you have left inside? Negative 3 times what makes 6x? Have to be 2x. And negative 3, you got to be careful here. Negative 3 times what makes negative 3? It's going to be a plus 1. Notice that what's inside the parentheses is the same. It has to be the same. 2x plus 1, 2x plus 1. Now I'm done. I have my 5x. I have my negative 3. They go together. And I have my 2x plus 1. The other 2x plus 1 is what allowed me to group the 5x and the 3 together. So you don't have 2x plus 1 twice. You only have it once. Let's try it one more time. If we're lucky to get in 2 more times. So first of all, is there a GCF in this? No, there's no GCF. So the best I can do is factor out, to do my A times my C, which is 60, that adds to be 19. I know my two signs have to be the same, either both positive or both negative. And because they add to be a negative 19, they have to both be negative. So negative 1 and negative 60. Negative 2 and negative 30, negative 3 and negative 20, those are all ways to multiply to be 60. None of those add to be 19. Negative 4 and negative 15, hey, that adds to be negative 19. I did it. So I'm going to start with my 6x squared, bring over my 4x, my negative 15x, and end with my plus 10. Group my two terms together, and that leaves me with 2x and 3x minus 2 inside, because when I distribute this back in, I have to be able to produce that. Bring down your negative, factor out your 5, negative 5 times 2x, actually 3x, 3x makes 15, and a negative 2 makes my 10. And I'm done. Those two terms come down. 3x minus 2. Our last example here. I see that they're all even numbers. I also see a negative in front. I don't like negatives in front of the x squared. So I'm going to factor out a negative 2 out of each one of these. That's going to leave me a 3x squared, a negative x, and a negative 4. When I multiply this back in, I get negative 6x squared, positive 2x, and positive 8. Now I'm going to work with this trinomial. Multiplying to see what gives me negative 12 and negative 1. I see that that's going to be 3 and negative 4. If you know what the factors are, you do not need to write out all the other factors. But if you're not sure, I've tried to give you the pattern of what you should follow. But if you can figure it out, use that. So you're going to start with your 3x squared, and a positive 3x, and a negative 4x, and then you end with your minus 4. Factor out what you can out of both groups. That gives me 3x, x plus 1, and my negative. Factor out what you can. That leaves me with x, because negative 4 times x is negative 4x. Negative 4 times 1, positive 1, gives me negative 4. And I'm all done. 3x minus 4, x plus 1. Now before you finish, you always need to remember to write down your GCF. Include your GCF.